And the symbol for coefficient of friction is a mu. It looks like a U with a stem up front. This is a Greek letter mu. You would have seen it once before when we did the test level problem of the plus minus 0, and I had the frictionless area, and I wrote mu is not equal to 0. That was to indicate that there was friction. So if mu equals 0, then it's frictionless. So let's write that up as a sort of a side note. Frictionless, mu equals 0. Now, what causes it? What is it about the surfaces that causes friction? I'm going to give you two theories. The second theory is gaining a lot more support, but the first theory is what I call the Nook and Cranny model. That if I have a table here, and I have a book sitting on top, or a box, or whatever it happens to be, if I zoom in on a small little section right here, that the book has all sorts of nooks and crannies in it as you get down on a much smaller level. And the table has its own little nooks and crannies. So it's kind of like I've got these two different objects and they're sort of nestled in there, and you're trying to overcome that. The greater normal force means they're getting pressed more tightly together, and so they're more interlocked. Thus, normal force increases friction. Once you get it moving, so it's sort of, if I imagine I got my knuckles embedded like that, and it requires a certain amount of force to undo it. Or if it's already moving, they're not going to quite nestle in as much, even though they're being pushed on the same. And so in this model, they do differentiate between static and kinetic coefficients of friction, or static and kinetic friction. So static friction and kinetic friction. Static friction, they went all out on the cleverness here. It's the symbol for friction with a little bit of an S, the little S down there, subscript. Kinetic friction, yeah, you guessed it. There's a K down here. Static friction depends upon the coefficient of static friction. Depends upon the use of S. And kinetic friction depends upon the coefficient of kinetic friction. Use of K. Use of S is always greater than or equal to use of K. Labs, not necessarily, because labs, it's a physics lab. Why would you expect it to actually match? But the idea is let's do the book so that'll be easier to lift up. I'm going to lift up the table. At some point, the book's going to slide. Once it starts sliding, it's really easy to keep going. And that's this aspect right here. It's hard to get going, but once it does go, it's going to be easier because this coefficient is smaller than that one. Almost every physics textbook will talk about the two different kinds, static and kinetic. Not every textbook will, though. Let's talk about the other model. Questions to hear before we talk about the other model, actually. the attraction model. The attraction model is, if we zoom in there, we don't have to worry about nooks and crannies. What we worry about is the fact that there are bonds forming between the atoms in the book and the table. And when you have a greater normal force on it, the atoms are closer together and they form a stronger bond. And so you're trying to break the bond. It's a weak bond. I mean, most of you have managed to slide one thing over another. In the attraction model, by adding a lubricant here, you're potentially changing the bond here to make it easier to slide. There are two schools of thought on the attraction model. School of thought number one, the first time I actually saw this model, is the fact that there really is no differentiation between these. That the experiments that are done has such large error bars that there's just the coefficient of friction, static or kinetic, there's just one number. In other words, mu s is close enough to mu k. The other school of thought is it's still, once it gets going, it's still easier to move, and so you still have mu s is greater than mu k. So the first textbook I saw which talked about this model, this is the tack that they took. The physics textbook I'm using with the calculus-based group, they talk about they use the attraction model, but they still have mu s greater than mu k. And I recognize all I've done is write up letters, and we haven't actually talked about this. I haven't really dealt with a specific application yet. We'll get there. Questions on this before I actually bring up a formula? Because who doesn't love a formula? So back to the book. I have the book on the table, and I tilt it up like this. Is there friction acting on the book?
No.
Is that no or yes?
Yes. No.
Why not?
Because it's not moving.
Ooh. If there were frictionless surface, would the book move?
Yes.
So therefore, friction must be acting on it to keep it from moving. It's static friction that's keeping it from moving. Matter of fact, we don't even need to do the book one. I'm going to push on the table. I'm pushing on the table right now. Is the table sliding? Is it sliding now? I'm applying more force. I apply more force. Is it sliding yet? And now it starts to slide. The friction is going to be just enough to keep it from moving. The static friction will be just enough to keep it from moving until I hit a breaking point. So under this model right here, the Nook and Cranny model, or under this aspect of the attraction model, if I look at friction versus applied force, that the friction is going to match the applied force until I hit that breaking point. At which point, the friction will drop down into something like this. So this point right here, this is the maximum static Fs max, and this right here would be my kinetic friction. Under this model right here, if I did the exact same thing, I'd have my friction over here, and I have my applied force over here, down here. That the friction is going to match my applied force until I hit that breaking point, at which point I get whatever the friction is. Two very distinct predictions, and yet they still haven't figured it out yet. So why have we not figured it out? Because these graphs definitely look different. So why what?
Why does it drop down?
Kinetic friction, because kinetic friction is not as big as static friction. That's the US is bigger than UK. That once you reach that breaking point, the amount of the friction that's actually acting against this smaller.
Okay.
So So I got 2 questions there. I got one, where's the formula? And 2, why have they not figured out why have they not figured it out? So first formula. Static friction is less than or equal to USY. The less than or equal to is the fact that US times Y is the maximum static, and that the friction is going to match whatever's needed to keep it from moving until it reaches that breaking point. Kinetic friction is just UK times Y. Doesn't care how fast it's going, doesn't care about anything except for that coefficient, the surfaces, and it cares about how tightly they're pressed together. And then the other one of why have we not figured it out? Because physicists, for the most part, don't deal with friction. I don't think I dealt with friction at any point during my graduate studies. Friction is primarily an engineering thing. Engineers have something that works, they're very practical as a group. Engineers have something that works, so why bother figuring out the difference? They got something that they can use. So physicists don't deal with it much. Engineers, it's not worth their time, for the most part. There is a group at NC State who's trying to pin down, trying to come up with something better. This formula here, 1790s. It has not been changed really since then. Anyway, again, rushing through things because that was the end of class. And when running out of time, go faster instead of waiting until the next day. Just wait till the end of the semester. 5 chapters covered and we have only 1 day left. We can do it. No Matthew, you can no shot.
Get a couple extra sheets of wrapping paper.
Yeah.
Thank you. Did you get them? Let me know if you want to get it together tonight. Did you get mine? Do you want to do anything, or if you don't have time, we'll try to take tomorrow. We usually do around 8 or 8:30 on Thursday.
By the way, I'll hand the quizzes back on Friday. They're graded, I just haven't recorded the grades yet. Or I have raw scores, I haven't put a grade on them yet. Guess that's a front and back kind. These are fronts. These are front and back, but not as evenly marked.
I have a question about the last. I was wondering how I could make sure that these were, that this was, the result was 0. Because when I did the Pythagorean theorem with these numbers, it like checks out perfectly. And then when I through it, it was like,
on Thursday usually works best for her.
All right, do you want me to
it
look at
was
it?
like millimeters off, so I didn't know if that was like.
If it's millimeters off, then
Because they're
Yeah.
like 1 millimeter, so.
Whenever today, if you want to.
And since the numbers worked out that way, I didn't know like what else to check to make sure it was correct.
all right, so
Today,
what I'm gonna do is I'm gonna check each angle and each distance. So the short one is 7, so this should be
Figure all that out. And I go through that today, if either of you.
7 point, well, actually, I
As
usually
well,
look this
that
way
would be
first,
wonderful.
and then I look to see what it should be.
So that way tomorrow.
So that's on the tipsy area
And
there.
then probably by the time I watch the video.
So that looks like 7 point,
And that's fine. If y'all wanna wait till tomorrow, that's fine. If you wanna try.
That's like
to work on it
7.25.
tonight, Or whatever it works best for
like
you.
a 7.25, not
I'm usually more
7.35.
available after 8 o'clock after my kids go to sleep.
This, I guess, is what it should be
Because they're all
normal,
over
right?
me if I'm trying to do something.
because when I talked talked to my group about it, and they said that it was
Evenings or.
0, so they're not drawing resultant, so I didn't know if I drew one and they didn't, I would get points taken.
No, it depends upon,
Pick my kids up from the babysitter. So.
no, at this point, it's an
If I can
analysis.
ever work it out.
There'll be some
Then
differences.
after
I mean,
class,
if you're a half millimeter off what they have, then I can change everything. To me, that's looking like,
Tomorrow evening,
Yeah.
tomorrow night, okay. Okay, that works, then I'll watch the videos, we'll go back through it again.
yeah, that looks like a little bit more than 9.7, instead of 9.8. It looks closer to 9.7, 9.8 from what I was doing just then.
Under this
And
lab,
then
there are videos that you
that
can.
is,
Oh, yeah, here, let me give you the information I have. Alright, what?
that was at 12.2, you 12.25.
It's a recurring, I have to. go through
So
it.
that's
I have to
one of the
set
things
it
I'm
up as a
doing when I'm
recurring
looking at it.
thing.
I probably would
I'm
take
ready to
off a
do it
point
as a
for each of
recurring
those,
thing.
yeah, but not for that one, that was within the margin.
We
Another
have
thing to keep in
different
mind
times,
is
so.
the
But it's
tip
always
of the
going to
arrow
be the
should be where
same
this one begins,
password and the same-
and the way you've drawn it right here, it is just slightly off of
Yeah,
the tip.
that's where the difference is like the 1 millimeter, cause I've redrew this like so many times. Cause I was like trying to get it to work out right, cause these numbers worked out, so I didn't know
I'm
like,
gonna copy it right now.
should I believe the graph or like the numbers?
I'm gonna put it to the
So,
group
because I didn't
chat.
know what else to check for the numbers to make sure that it was
There you
0,
go.
because
And the password
if
is
it
being
is slightly
sensitive,
off,
just
I
so
didn't
you
know
know.
if I should
So.
make a resultant of like the 1 millimeter.
Yeah, if it comes out 1 millimeter, then you draw a result, and it might be this tiny little thing you're drawing right there.
Yeah,
But
yeah.
then 1 millimeter or 0.1 centimeters would translate to some tiny little amount.
Okay, and you consider that analysis,
If you can't find it at the dollar store.
or is that?
Oh,
part of
oh,
data?
and that is, no, this is the data
They're
right
not
here.
too terribly expensive.
Okay.
Not that, that's the data right there.
Okay.
I guess
Yeah,
those two
they're not
numbers,
too terribly
that's the
expensive.
data.
If they're $2.
That's a
So does this
calculation.
need to match up with?
It's a piece of.
That needs to
My
match,
lab
no,
numbers?
no, that needs to match up with what you have for one.
Okay, so it's okay if mine.
Yes.
Okay, cause I think I'm gonna redraw it and
Nice.
get that really small result. that I
Bonus,
had before.
get two pencils.
So, but theirs was 0, so I didn't know.
Yeah, and I'm gonna do the same thing with them, did they force it to 0, or did they actually do it, everything? I also did not check the angles just now. Is that really a 126-degree angle, or is that 125, or?
Okay, okay, then I'll change that then and add that
Okay.
millimeter. Thank you for looking at that.
Yep.
Thank you. I have one really quick question for you,
Yes,
and then
ma'am.
I'm gonna go. As far as doing when you're doing the calculations for the,